Let's go ahead and draw the common emitter with a dual power supply, and this time we're going to look at the AC equivalent for this circuit. So let's say we have RC, and that's connected to VCC. So that's the first power supply. Here's our transistor. Same collector, emitter here, and our base here. So we're going to see something slightly different in the way we configure this. This is still a common emitter, which means I am going to come out from here and load up my load RL versus some sort of a reference. Okay? Now RE here is no longer connected to ground, but it's going to be connected to, let's go ahead and do this, minus VEE. So hence we have two power supplies. We have one negative and plus VCC, one positive on this end. We're going to see a lot of amplifiers in the future that have dual power supplies, and we will learn the reason why. The important part is no matter what, vis-a-vis ground, if you have a resistance to control the amount of current that goes into the base, the idea is still in DC, the base emitter junction is forward biased, which means I have a VBE drop this way. Okay? And sure enough, I mean, if you think about it, this here being ground is at a much higher level or at a higher level than a negative voltage, which means if we're carrying this to here, this is still a positive voltage vis-a-vis a negative voltage. So definitely we are going to be creating some sort of a forward bias as far as we're concerned, since this is at a higher potential than this. Okay, remember that when we have an arrow here for voltages, which means this is the plus and this is the minus, if you had to draw this in DC. Now remember, this thing here will also have some sort of an input. Let's call it V in here, right? Vis-a-vis ground. Okay, so can we bypass RE as well vis-a-vis ground? And the answer is yes, we could do that. So if you don't want RE to come into the circuit, then you can bypass it as well. Okay? All right, so how do we draw an equivalent circuit for something like this? Let's start from the input. So I have my AC source, Vn. Okay, and let's draw a ground here. And we can bypass this completely since it will be a short. And notice that RB will be drawn in this manner, still to ground. So everything vis-a-vis that reference. Now we're still here at the base. So this line here is still the base. And we're going to use the pi model again. So that means if you think about the emitter here, it's also to ground, since this takes you to this ground. So that's fine. So this goes to here. And if that happens, that means if it didn't, RE would be here. But it isn't. So this line is straight to ground. And this one here is beta RE prime. So it's not any different than the previous circuit we've observed. At the collector side, we still have a current going to ground in this manner. This is the collector. You have RC, and again, going to ground in this manner. And the reason is this is ground as far as we're concerned in AC. Okay, so is this. Okay, so what else? Well, this coupling capacitor also, we can short it, and we have RL to ground in this manner. So this is the equivalent circuit. Okay, so if we're going to go to AC, so this is the AC equivalent for the circuit above with a dual power supply.